Let's now look at geometric series. When working with geometric series, the formula to use is Sn is equal to A into r to the power n minus 1 all over r minus 1, where Sn is the sum value of the pattern, A is the first term, n is the number of terms in the series, and r is the ratio, where r is calculated as T2 divided by T1 and so forth. So we're given our pattern here, which is 5 plus 15 plus 45 plus 135, so on until 3645. So we need to determine what type of series this is, justify it, how many terms are in the series, and calculate the sum of the series. So what type of series is this? We know that this is a geometric series because we are multiplying by 3 all the time. 5 times 3 is 15, 15 times 3 is 45, and so forth. Let's calculate the number of terms in the series, just like how we've done before for arithmetic series. You start off with the general formula, which is Tn is equal to 8 times r to the power of n minus 1, where Tn can be represented as the last value in the sequence. And that last value is 3645. So 3645 is equal to A, which is 5, r, which is 3, to the power of n minus 1. So 3645 is equal to 5 times 3 to the power of n minus 1. We need to solve for n to calculate the number of terms. So we need to get rid of the 5 first. It's 5 times 3 to the power of n minus 1. So we need to do the opposite of multiplication, which is division. So 3645 divided by 5 will give me 729, and that's going to equal to 3 to the power of n minus 1. Now we have a prime base here, that's 3 on the right hand side. We should be able to get a prime base on the left hand side that is also 3. I know that 3 to the power of 6 is 729. So instead of 729, I can write 3 to the power of 6. So my equation is now 3 to the power of 6 is equal to 3 to the power of n minus 1. Because my bases are the same, I can cancel my bases off, and I'm left with 6 is equal to n minus 1. Solve for n, and I'm going to get that n is equal to 7. So there are 7 terms in the series that was given there. Let's calculate the sum of the geometric series. So to calculate the sum, we need to use the sum formula for geometric, which is Sn is equal to A into r to the n minus 1 all over r minus 1. Remember, we need to know what n is in order for us to calculate the sum. So wherever n is, we need to calculate what we worked out previously. N we worked out to be 7. There were 7 terms in the sequence, in the series. So wherever n is, I will put 7. A was the first term, and that was 5. And r was a constant ratio of 3. So wherever I see r, I will replace r with 3 in the formula. So S7 sum to 7 is equal to 5 into 3 to the power 7 minus 1 all over 3 minus 1. Put that on your calculator, and your final answer for the sum of the series is 5,465.